Yeah, hello everyone and welcome to this another session on ensemble learning. So we are going to wait for another 5 minutes. Let everyone join, then we will start off with the session. We will wait for another 3 minutes and then we will begin the session. Yeah, hi everyone and welcome to this another webinar on ensemble learning technique and this series of free webinars by Codegnan IT Solutions. I'm Manvendra Singh, machine learning developer at Codegnan IT Solution, and today we will talk about ensemble learning. So if I am audible and you can see my screen clearly, just write yes in the chat box and we will begin off the session. Okay, so let's get started with the session. I hope everyone can hear me clearly and you can see my screen. So we are going to start off with this ensemble learning. So first of all, let's understand what do we mean by ensemble by using a simple example here. All right. So let's suppose that you are going to buy a phone. All right. So you have to think of buying a phone, but you are not sure which phone you should buy, but you have a budget here, right? In that budget, you are trying to get a phone for yourself. Now, will you go to the store directly and buy a phone whatever the salesperson suggests you? No, right? You will do some research, right? You will ask your friends, do some research online, watch some videos, right? So you are going to do some research in back. Then only based on the reviews, based on your research, based on the person that you have asked, you are going to make your decision, right? So you are taking all their opinion in consideration here. Then only you are going to decide which phone is best in this budget for you. Then only you are going to buy that phone, right? So this is the ensemble learning idea here, all right, where you take this informed decision from your multiple persons here, all right. So this is your ensemble learning idea of ensemble learning. So let's get started. There are many different concepts in ensemble learning that we are going to demystify today. So let's begin. So pardon me if my voice is little off today. So ensemble method is a technique that combines several base models in order to produce one optimal predictive model. All right. So like I have given the example that you take the feedback from everyone before buying the phone, right, or before buying any appliances either online or offline. You don't just go to store and buy that stuff, right? You do some research, ask your friends, and you check for different websites where they provide the feedback, suggestions with what is the good for you in that budget, right? So it is the idea of ensemble models here, where you combine different models, the prediction of different base models, and you try to build a one optimal predictive model which can give you a far better result than your single model here, all right. So this is the idea of ensemble learning. So here you build in machine learning, we build these several base learning models. That is, let's say here we have model 1, model 2, model 3, and then you take their prediction, all right. So we take all the prediction and then we combine their prediction or their decision to build our final model here. So this is our ensemble modeling. Now in ensemble modeling there are two types. So there are two types of ensemble models. One is bagging and other one is boosting. Now what is bagging and what is boosting? We are going to look into that. So first of all, we are going to talk about what is bagging here. All right. So bagging or bootstrap aggregating. All right. So we use both the names, that is bagging or bootstrap aggregating. Don't get confused by seeing this different words used in different books or different blog posts. So many people get confused. These are the same terms, that is bagging or bootstrap aggregating. So bagging is a way to decrease variance in prediction, right? So this is a way to decrease the prediction in your variance. So you are predicting something and the result is something else, right? So we want to decrease it. We want our prediction to be as accurate as possible by training several decision trees. All right. So here we are building several decision tree models, not just single decision tree, but we build, let's say, 100 of 1000 of decision trees, and then we combine their prediction. This is your bagging classifier. All right. So here you have this decision tree 1, then we have decision tree 2, then we have decision tree 3, and like this you build n number of decision tree and then you combine their prediction. All right. So here if I combine this 4 trees prediction, then obviously I am going to get a good model at the end, right? Good prediction at the end, because not just by single tree, but here I am taking the prediction from all these trees and they are built using different decision models, by these different decision boundaries, decision models here. All right. Now let's understand how this bagging works. All right. So how do we build this bagging classifiers? So I hope you know how to build a decision tree. All right. So if you are not aware about how to build a decision tree, you can watch our video that is there in our YouTube. So we have taken this webinar on decision tree models. So you can watch that and you will know how we build this decision tree, how we decide the best split. All right. So here let's talk about how we build this bagging classifiers. So we have our data set, right? So this is our all data set. Now what we do is we divide this data set into different samples. Let's say sample 1, sample 2, sample 3, sample 4, and till sample n, let's say. So we have n number of samples from this data set. So on this n number of samples, what we do is we build a different model. So on sample S1 we build model M1, on sample S2 we build this model M2, and like this we build n number of different models on this different samples which are taken from our original data set here. All right. So we have built this n number of models. Now what we do is this model is going to give you some prediction. Let's say this model is going to give you some prediction here. Let's say 0 again, then here again this model M2 is giving us prediction as 1, and this model M1 is giving the prediction as 0. So here if you see, we have got 0 3 times and 1 just a single time. So what we do is we take this all the prediction of these models from different n number of models, then we take the maximum vote, or you can say we take the mode here. All right. So we take the maximum vote, and here if you see, the maximum vote or the mode here is for class 0. So we classify this as 0. So here why do we call it as bootstrap aggregation? Let's understand that. So here what we are doing is, from our original data set we are creating n number of samples, right? So this is your bootstrapping. When from a single data source you create different samples, that is your bootstrapping. And here after building this model we are doing this aggregation here, right? So we are taking this maximum vote to classify our final class. So this is your bootstrap aggregation, or you can call this as bagging classifier, and this is an intuitive understanding of how this bagging classifiers work. All right. So let's take an example here. All right. So here in bagging, what we do is we take the row sampling, but we also take it with replacement. Now we take this row sampling with replacement. So there is a chance that the same data points get selected multiple times. Alright, so here if you say I have OBS, that is observation 1, 2, 3, I have X and Y. Alright, so here I am taking this sample 1. So here if you see in observation we have taken observation 3 multiple times because we are doing this row sampling with replacement. That's why there is a chance that the observation that has occurred in one sample might again occur in different sample or the same sample. Alright. Then here we have this sample 2. So here we have 2, 3, 1. So there is no same sample here, observation here, right? And here again we take this observation, and here when doing this sampling we see that this observation 2 has occurred twice. So this is why, because we are taking this row sampling with this replacement. Alright, so there is a chance that same data type data points get selected multiple times. Alright, now let's talk about this random forest. So random forest is a type of bagging classifier that is built on top of decision trees. Alright, so random forest, in random forest classifier what we do is we train several decision tree from this selected subset of training set. From our original data set we take different subset, then we build different decision tree, and when we combine their prediction, that becomes your random forest classifier. Alright, so it aggregates the votes from different decision tree to decide the final class of the output here. Sorry. So here we have built this n number of tree, let's say here tree 1, tree 2, tree 3 and tree 4, and then we have different prediction from these different trees. But here again if you see we take the maximum vote, or you can say we take the mode. Alright, so here if you take the maximum vote it is going to be 1. So this is your random forest, how it works, and this is similar to your bagging classifier. So this is a type of bagging classifier only that is built on top of this decision tree. So here let's take example of this random forest, how it works. Alright, so here not only this row wise we take this samples with replacement, but also we take the sample of different features as well. So one feature might get selected in one sample. Alright, so here we have 3 samples. So here we have this observation 0 and 3, and we have this P and S feature only. Alright, and here in sample 2 we have 4 and 0, and here we have P and C. And here again this is observation 0, 1, and here the features that we have selected is S and P. So here not only row wise sampling, but also the sampling is done for different features as well. Alright, so this is your random forest classifier and how your bagging classifiers work. Now we have talked about bagging classifier. Alright, now let's talk about this boosting classifiers. What are they and how do they differ from bagging classifier? Alright, so bagging is family of algorithms that converts weak learners into strong learners. Boosting is a sequential process in which more weightage is given to misclassified instances after every iteration. So it might not be clear to you right now, alright, but it will be clear after we finish this slides here. Alright, so let's move forward. I know it is not clear to anyone, but be patient, it will get clear after 1 or 2 slides. Now here let's understand the difference between bagging and boosting, then it will be more clear here. Alright. So here we have seen the bagging classifier, right? So we have these data sets, then we take the n number of samples from this data set. Based on this n number of samples, what we do is we train n number of models, right? From this n number of models, we build our final model, final predictive model that takes the prediction from all these models here, right? So this is your bagging classifier. So we build this multiple decision tree, but here if you see, we are doing it in parallel. We are building this different n number of models parallelly, right? And here if you talk about this boosting, here you have this data set, and initially there is no weightage or no weightage assigned to any data point. Alright, so you build a simple weak learner at first iteration. So here we build this simple weak learner M1. Alright, and after building this M1 model, there is going to be some misclassified points here, right? So here what we do is we give more importance to this misclassified points from this model M1, and again after giving this misclassified points some weightage, we build this model M2, and this time we have assigned some weightage. Remember, we have assigned the weightage to misclassified points only, and again we are building this M2 model on our original data set with some weightage given to misclassified points. So this is your model M2. Then again there is going to be some misclassified points from this M2 model, right? Again what we do is we again assign the more weightage to this misclassified points from model M2, and it keeps on repeating this process, and finally you have a strong learner, a strong model for you that will do a good job than these weak learners. So this is your boosting, and here it is not building the different models, weak learners, in parallel. Rather it is a sequential process where more weightage is given to misclassified instances after each iteration, right? So this is the boosting classifier, difference between bagging and boosting. I hope it is clear to everyone. All right. Alright, so how boosting algorithms work? Let's talk about that. So here we can define this working of this boosting algorithm in these 4 major steps, right? So here at first step what we are doing is we take this base learners and take all the distribution, all the data set, and assign equal weightage to each observation and build our model, right? So this is your step 1. Now at next step, that is step 2, if there is any prediction error, so if there is any misclassified data point by first base learner, then we pay higher attention to the observation that have prediction error or that has been misclassified. So here you assign some weightage to misclassified points by your weak learner 1. Then again you apply the next base learning algorithm by giving some weightage to this misclassified points. And then here at step 3 you iterate step 2 until the limit of base learning algorithms is reached. Either the limit is raised of this base learning algorithms or you have the higher accuracy possible to achieve, highest possible accuracy. Alright, so you keep on repeating this process 1, that is step 1 and step 2, by giving some weightage to misclassified points till the point where your highest accuracy is reached or your limit has been reached for the maximum number of iteration. Alright, and at step 4, finally what you do is you combine the output from these weak learners, which eventually improve your prediction power, right? So if you combine all these decisions from all your big base learners or weak learners, then eventually you are going to have a improved model, right? Now here let's understand how it works here by some example. All right, so here let's think of this as a D1, D2, D3. All right, so we call these as decision stumps. So think of this as base learners. All right, so you have this D1 here. So we want to classify this positives and negatives. So we want to separate these two classes, that is positives here and the negatives. All right, so here after building my this first base learner, this comes out to be my decision boundary. All right, so anything on left of this decision boundary is going to be classified as negative points, and anything on the right are going to be classified as positive. So this is your decision tree 1. But here if you see, we have made some mistake, right? So we have misclassified these 3 positives as negatives here, right? So we have misclassified these positives as negatives. So what you will do is you are going to assign more weightage to these 3 positives which has been misclassified. All right, so you have given some weightage to this misclassified positive points. So in next iteration, here you have more weightage for these positives. All right, so here you have built another decision boundary, and anything below this decision boundary you are going to classify them as negatives, and anything above this decision boundary you are going to classify them as positives. But here again, if you see, you are doing some misclassification here as well, right? So here if you see at D3 you give this importance to this point which has been classified as negative, but which has been classified as positive, but in actuality this class here that you see here, it is classified as positive, but in actuality it is a negative point, right? So here you give more weightage to these points here, this single point here. So you come up with this decision boundary over here. So here if you see, you have built another decision boundary, and here if you say anything that is present on right side of this decision boundary is going to be classified as negative, and anything that is on the left of this decision boundary you are going to classify this as positive. Alright, so now what you do is you have these 3 decisions, right, from D1, D2, D3. They have different decision boundaries, right? They have different decision boundaries to separate these 2 classes. So what you do is you combine their decision boundary, you combine their predictive power, alright, and come up with a final model that takes the leverage of all this decision tree that you have built, or your base learners that you have built, and finally if you see, you have built this decision boundary which does a good job separating these negative points and positive points. And here if you see, there is only one misclassified points, and that is acceptable. It is way more better than your decision tree 1, decision tree 2 or decision tree 3. So this is your boosting classifier. Alright, so this is your boosting algorithm, how it works simply. And if you see, these are used more these days in these hackathons that you see on Kaggle. These are mainly used there. And if you go to Kaggle, if you don't know anything, just apply this XGBoost or some boosting algorithms, you are going to get a good accuracy score or good leaderboard score for sure. So this is your boosting algorithm. Alright, so here let's talk about some most popular boosting algorithms. We are not going to dive deep into them because we also have to demonstrate you, right? Our session are going to be hands-on, so we cannot dive deep into these algorithms. You cannot go in mathematics parts, so let's talk about them. So we have AdaBoost, gradient boosting and XGBoost. There are many other boosting algorithms, but mainly if you see, these are widely used. And if you talk about these days, you mainly use this XGBoost, right? So here, if you go to any competitive or hackathons, you will see that mostly this XGBoost classifier are used, and they work the same way that we have talked here. Alright, they build different base learning algorithms, then they combine their decision power to make a final model. Alright, so they work in a similar way. There is a little difference. You can read about that if you are eager. We are going to go to our practical part now, and don't worry, this time this is not going to be your Iris or Titanic data set, but we have to work with smaller data set, because if we go for big data set, then it takes time to run our model and to explain you as well. That's why we choose the smaller data set, because we cannot wait for, let's say, half an hour to train our model, right? That is not feasible. So if you wait for half an hour to train our model, then you will switch off, turn off your phone or your laptop, right? So that's why we come up with some medium sized data set, so we can work with that. Alright, so if you have any doubt, anyone in theory part, you can ask your doubts. Otherwise, we are going to move to this practical part here, and here we are going to work with bagging classifiers. All right. So I'm going to connect here. So first of all, you have to import all the packages. All right. So we are going to import all the packages that we are going to use here. So here I'm going to import all the necessary packages, all the packages. All right. And here I'm going to import pandas as PD, sorry, and import numpy as np, then import matplotlib dot pyplot as plt for plotting our graphs, and also we are going to import seaborn as SNS. All right, then to run it, just press shift enter. All right, so we have imported these packages, and rest all packages we will import it when we require them. All right, so here let's read our data. So here data equals to PD dot read and underscore, as it is a CSV file, so you have to give pd.read underscore CSV. If it is some other file, let's say Excel file, then you have to specify pd.read underscore Excel. And if you see, there are many different options that you can see: read pickle, read JSON, read HTML, then SDF, right? So we have Excel, so that, sorry, this is CSV file, so we have pd.read underscore CSV, and in braces you have to give the path. All right, to get the path of this data set, you click on this folder icon here. So click on folder icon, then mount this drive. So mount drive, all right, connect to Google Drive. Then if you see, we have this option of drive here. Then click on drive, then go to my drive, then go to the folder where you have stored this data set. All right, so I have this data set. Let me check just a second. Yeah, here it is. So we are going to work with this loan prediction data set. So I'm going to copy it, then close this, then I'm going to paste the path over here. All right, and now let's run this. So we have imported this data set. Now let's check the head of this data set. To check the head, you can give data dot head, and here if you run it, we'll have a top 5 values of this data set. So check the head of this data set. All right, so here if you see, we have this data set, where we have this loan ID, we have gender, then we have married, number of dependents, then we have education, then we have this self-employed, then applicant income, co-applicant income, loan amount, then what was the term of that loan amount, credit history, whether the person has any credit history or not. Then you have this property area, where this area is located, whether it is urban or rural. So then you have loan status, whether it has been approved or not. So here you have Y for yes and N for no. All right. Now let me get some new code cells. So I'm going to click on code. So we are going to require this code cells. All right. So first of all, let's check the size of this data set here. So check the size of data set. All right. Now to check the size, you can give data dot shape, and if you run this, you will have the number of rows and number of columns in a tuple form. All right, so this is a tuple where you have this first value 614, that means your number of rows. So you have 614 number of rows and 13 columns or 13 features. All right, now if you want to check the column names, so check the column names, you can give here data dot columns, and here if I run this, I will get a list of all the columns that are there in my data set. Right, so here we have this loan ID, then we have gender, then we have married, dependents, education, and all these features that are there in our data set. Sorry. All right, now let's check the info of this data set. So check the info of this data set. Now to check this info, you can write data dot info, and it is going to tell you what is the data type, what is the non-null count, right? And here you can see it is a pandas code dot frame dot data frame, and range index 614 entries, total of 13 columns, then you have this column name, then non-null count, then this data type. Alright, so you have this object, and here as well there are object, that is gender, then you have dependents, this is also object, right? Then you have int 64, this is applicant income, then you have float 64, this is your co-applicant income, and here if you check this D types give you the different data types that are there in your data set. So here we have 8 number of features that are object type, then you have 1 int 64 type and 4 float 64 type, and you can also check the memory uses here. Alright. Alright, so now let's move forward. So we have checked the size, we know the columns, we have checked the information, right? So now if you want to know how many null values are there in your data set, right? So to do that you can write, so check the number of null values in each column, and here you can write data dot is null, and if I run this by just writing this command, that is data dot is null, I will get only true and false here, right? But we don't want this true and false, we want to know how many null values are there in this loan ID, how many null values are there in this gender, how many null values are there in this married column, right? To do that you can write dot is dot sum, and here it is going to give you the null value count in each column here. So here you have this gender, in gender you have 13 null values, in married you have 3 null values, in dependents you have 15 null values, in self-employed we have 32, and in credit history here if you see this credit history here we have 50 null values, that is the highest, right? Then you have loan amount term, there are 14 null values, then self-employed 32, right? So you have to come up with something that you can fill these null values with, or either you can delete this null values, right? So we only have 600 and something number of data sets, so let me check that 614. If we delete this 50, then we are going to lose this information as well. So you have to think about this, where you are going to drop this null values or you want to keep it. It all depends on your observation. Alright, so we are going to keep it, we will fill with something. Now let's see if we can spot or see any pattern in this null values. Now to do that I can write SNS dot heat map, alright, and here you can give data dot is null, and if you run it, it is going to give you a heat map plotting this missing values, right? So here whenever you see this white color or the light shades, that means these are your null values, alright, and these are your indexes at which these null values are present. So I don't think we can see any pattern in this null values, right? There are no such pattern visible through this heat map. So you have to think of something else. So we will figure that out later. Either we can fill this with mean, median or mode, and there are other different ways, that is forward fill, backward fill. You can read about them, right? What is forward fill, what is backward fill, and what is interpolate, and there are different ways. So you can use some algorithms to find these values for missing values, alright. So there are different ways to fill this missing values. We are not going to dive deep into that. So let's move forward, and here let's check the description. So let's check the description of null values. Sorry, not null values, all the features that are there. So you have to write data dot describe, and if you run it, let's just run it, you are going to get the description of this numeric, either int or floating type values only. All right. So here you have applicant income, co-applicant income, loan amount term, then you have this credit history. All right. So here if you see, the mean applicant income is 5403, right, with the standard deviation of 6109, that is very high, right. Then the minimum is 150, maximum is 81,000, right. So there are some outliers in your data set. So you have this 25 percentile, 50 percentile and 75 percentile. All right. And similarly you can check this for co-applicant income as well. And here in loan amount term, if you see, this is your, you have 600 non-null values, right. Then here if you see, the mean is 340. So these might be days, because anyone cannot give you a loan for 342 years, right, 342 years, that's very rare, right. So here you have this, maybe this might be 342 days, then you have this standard deviation of 65 and the minimum is 12. Now if you see here, if you see that the values that are present in these columns might be present in days, or they might be present in years or month, that is not very clear from this data, right. Here if you see, the minimum value is 12. Now I would not give you, if I am a bank, I will not give a loan to anyone who want this loan just for 12 days, because at the end of the day this is a business for the loan, sorry, business for the bank, right. And I haven't seen a bank giving loan just for 12 days. So this might be the number of months here, right, just for 12 months. But here if you see, there is this 342, 360, so this might be 1 year, right. This is 360, this might be days, right. So here you have to do you have to scale these features. All right. So you have to scale these features because there are different units, there are different units present in your data set. So this might be in month, then this might be in days, right. So you have to scale these features, but in random forest or decision tree you don't have to think much about this pre-processing task. So we can infer this information from this description here, and if you want to check the description of all the object as well as float and int type, then here you can give include equals to all. So I'm going to copy it, I'm going to paste it over here, and I'm going to give include equals to all. And here you will see you are getting this count, then you will get number of unique values, then what is the top count. All right. So in each feature you are going to get this frequency of this top count as well. So here in gender column you have 2 unique values and the top count is male, and out of 614 data points that you have, 489 are male only. All right. So most of the applicant are male. Then you have married, and in married you have just 2 unique values, either yes or no, right. And most of the people are married, and here the count is 399 for yes. Similarly, you can infer all these other variables, right? So after this, you have to go for exploratory data analysis. So this is a cycle of any project that you build. You have to build this, you have to understand your problem definition, then you have to understand your data set, right? And then you have to do some exploratory analysis to identify the key variables or to understand your data more clearly. So we are not going to dive deep into this exploration part. We will explore few of the variables, then we will move to our modeling part. All right. So first of all, let's see how many values are there for in our target values, right? So we have two unique values, that is yes, that is loan has been approved, and no, that loan has not been approved. We want to check the count for yes and count for no, right? Now to do that, you can plot this simply using, so get the count of, so we are going to get count plot for target feature, and here you can write SNS dot count plot, and here you can give data and it is loan status. Let's run it. All right. So here if you see, there is a class imbalance here, right? So yes have more than 400 values, right? So here yes has more than 400 values, and no has almost close to only 150 to 200 values, I think 200 values, right? So here there is a imbalance class for between this yes and no. So we have to think of some other metric. If you simply think of the accuracy score, it is going to give you a false result for your model. All right, so it will be better if you go for recall or some other metric. All right, so we'll see that we will simply draw a confusion matrix and see how well our model is working. All right, so this is the count of yes and no in your target feature, that is loan status. All right, now let's try to fill out this missing values. All right. So let's go down. All right, so here let's fill out this missing values. So if you see here, let's go up and see where we have these missing values. So we have this credit history, then loan amount, right? I'm going to copy it so I will have a better idea. I will not have to scroll down again and again. I'm going to paste it over here. Then let's go up. Let's go down, and yeah, I'm going to paste it over here. All right, let's remove this. All right, so we have this missing values in loan amount term, credit history, gender, married, dependents, and self-employed. So I'm going to comment this out. I'm going to comment it. So let's comment this. All right. So to keep it simple, we will fill it either mean or mode. All right. So we are going to fill it this object type with mode, and those which are of int or floating point, we are going to fill them with mean here. Right. So here you have loan amount term, right, and this is your floating point, right? Then you have loan amount term, then loan amount, these two values are your floating point or integer values. Then you have credit history, right? So it is going to be either 0 or 1. Then you have gender, either male or female, right? Married, you have yes and no. And in dependents, here it is going to be the number of dependents, all right? So how many dependents do you have? And here if you check the value count, so let's check that data, your dependents dot value counts, and now you run this. Here you have 0, 345 and 1, 102, then you have 2, 101 and 3 plus dependent, there are 51 data points, alright. So we are going to fill it with 0 only, right? So we are going to fill it with mode only, alright. And then you have this self-employed, and here it is going to be either yes or no, alright. So if you check the data as well, if you go up and check your data, here in gender you have male and female, in married you have no or yes, then in dependents you have 0, 1, 2 or 3 plus, right? Then education, then you have self-employed, applicant income, alright. So let's fill all these missing values. So ensemble learning is a supervised learning technique. It comes under supervised learning. Alright guys, so let's fill this missing values here. So here you are going to write data dot fill NA, alright, and here you give this curly braces, alright. So we are going to make a dictionary and you are going to fill this loan amount. So we are going to fill this loan amount, alright, and this loan amount is going to be filled with data loan amount dot mean. So we are going to fill it with mean value dot mean, alright. Then you're going to fill the loan amount term, loan amount term, and here it is going to be filled with the mean value as well. So we're going to fill it with mean here, data loan amount term dot mean. Alright, so now let's move forward, and then we have this credit history, credit underscore history. So I think it is capital C, yeah, credit underscore history, and here we are going to fill it with either 1 or 0, right? So here if you see, most of people does not have the credit history. So if you explore this, you will find out. I will leave it up to you to explore this data set, or if you get the time, I will explore that as well. And then after this credit history, we have gender. So we have seen the most top count is for male, right? So we are going to fill it with male, and then after gender you have this married, and most people are married, right, in our data set. So we are going to fill it with yes, alright. Then we have this number of dependents, so we are going to fill this dependents, and here we are going to fill it with 0 only, alright. then you have this self-employed, so it is going to be either yes or no. And if you check the description of the self-employed, most of are going to be no only. All right, so if you go up and check this description, right, so here you have no, right, and almost 500 values are no only, so it's better to fill it with no here as well. So we are going to fill this with no. All right, and then you have to give in place equals to true. All right, now let's run it, right, and now if you check your null value, data dot is null and dot sum, if you run it now, there should not be any null values, right. So we have removed all the null values, we have filled it with either mode or mean here. All right. So after filling this missing values, you can go for exploration, or let me get some new code cells. All right. All right, so we have filled this missing values here, right. So now we are going to build a bagging classifier, that is decision tree. This is a ensemble modeling, right. So this is a type of ensemble modeling. Before doing that, you have to remove this unimportant, these features that are not necessary to build this model, like loan ID. If you see this loan ID here, this does not add any values, right. So this is not going to add any value in your model, right. So this loan ID, you have to remove it. Similarly, you have to identify the other variables that are not going to add any value in predicting whether the loan is going to be approved or not, right. So you have to do that, and you can only know that by exploring this data set here, right. So for now we are going to remove this loan ID, and here if you check, if you go and plot this co-applicant income here as well, this does not add any value as well. So I'm going to keep it for now because we are not going to do some exploration, right. So simply we are going to remove this loan ID from this data set. All right, so let's remove this loan ID. So I'm going to remove this loan ID. So drop loan ID from data set. All right, so remove that. To remove that, we can write data dot drop, and here you can pass this variable name, which is loan ID. So I'm going to copy it simply, and I'm going to paste it over here. So I'm going to paste it, and here you have to specify the axis as well. So I'm going to give axis equals to 1. All right, so 1 for column, and you give 0 for rows. So I'm going to give axis equals to 1, and in place equals to true to reflect this in my original data set. All right, so let's run it, and now if you check, you won't have this loan ID in your data set. All right, so now before feeding this data in your machine learning model or pegging classifier or any ensemble modeling or building any algorithm, you have to first convert this categorical data into some numeric form by using some kind of encoding, either label encoding or one hot encoding, or there are different encoding techniques. So these two are basics that we use, that is label encoding and one hot encoding. All right, so here I'm going to do the one hot encoding, and to do that we are going to use this pd.enrich get dummies simply. All right, so you don't have to do anything, you don't have to import any packages. So all you have to do is, let's separate this into x and y. So here we have this loan status, and your loan status is your final output that you want to predict, right? So this is your loan status. So first of all, let's map them so it will be easier to know which one is 0 and which one we have converted as 0 and 1. All right, so to do that, I'm going to write sorry, so I'm going to write data your loan status dot map. All right, and here we are going to map this y with 1. So we are going to map this y with 1 and your no, that is n, with 0. So this is your target variable here. All right, so remember that this is your target variable. So we are going to update this directly in your data loan status, loan underscore status. All right, and yeah, let's run it. All right, so we have done encoding for our target feature. Right now we have to do this encoding for all this, that is gender, your married column, your dependents, then education, right? So this is either graduated, high school, or some values, right? Then you have self-employed, either yes or no. Then you don't have to do the encoding for applicant income, co-applicant income, loan amount and loan amount term. Credit history is already encoded in 0s and 1s. Then you have property area, then you have to encode that as well. So you have urban and rural area, right? So you have to do the encoding. So first of all, let's separate our dependent and independent features here. All right, so here separate independent and dependent features. So we are going to keep this independent feature in x. So x equals to, we are going to assign it as data dot drop. All right, so all the feature apart from your target feature, that is your dependent feature, are going to be in your s variable here. All right, so data dot drop your loan status, loan underscore status. All right, and here you have to give this x is equals to 1. So this is your x, and in y we are going to have our dependent feature. So y equals to data, and in this y we just want the loan status underscore status. All right, so let's run it. All right, now if you check your x, if you print just x and print your y, so in y you have this target feature, that is zeros and 1s. So we have converted them into zeros and 1s, and this is your x, where you have this all the independent feature, right? This is gender, married, dependents, education, self-employed, applicant income, co-applicant income, and this properties area. So let's encode them first. All right, so we are going to use this pd dot get dummies. So all you have to do is you have to write pd dot get underscore dummies. All right, and here you have to pass this data set, which is your x. So it is going to convert all the object feature, object data type that are there in your data set into this one hot encoding. So it is going to perform a one hot encoding here. So here we are also going to give drop underscore first. So drop first equals to true. All right, and if you run it, let's run it. Here you have all these features. All right, so you have converted them into zeros and ones. So you have done your one hot encoding without using one hot encoder package from this sklearn library, right? So this is quite easy and efficient to use sometimes, right? So here if you see, you have also increased your features. That is, now you have 15 features, 15 independent features here, right? Previously, if you see, we had only 12 independent features, right, and one dependent feature, but now we have 15. So we are going to store this into x. So x equals to, all right, now the next step is to separate this data into training and testing set. All right, so we have to separate the data. One is for training our model and the other one is going to be for testing our model here. All right, so let's get some new code cells. So we are going to import the package from sklearn dot pre-processing, from sklearn dot model selection import train test split. All right, and here you have to give x underscore train comma y underscore train comma x underscore test comma y underscore test equals to train underscore test underscore split, and here you have to give x comma y, that is your independent and dependent features, right? And here you have to specify the test size as well. So test size equals to, it is going to be, let's take it as 0.2. so 20% for testing and 80% for training or building our model here. All right, and you also have to give the random state. All right, so it is going to be random underscore state equals to, you can give any value that you like. All right, so don't change this value once you run this model. All right, so you have to keep it same throughout. So I'm going to keep it as 42 and let's run it. All right, now let's check the shape of training and testing data. So check the shape of training and testing data. All right, so here to check the shape, we are going to write print x underscore train dot shape comma y underscore train dot shape. All right, so I'm going to copy it, and similarly we are going to check the shape of our testing data. So just paste it over here and change this variable name, that is y test and x test. So y test and our x test here. All right, now let's run it. All right, so I think we have done some mistake over here. So we are getting 491, and here it should be x train x test, then y train and y test. So just you have to do a correction here, and this should be your y train comma y test. So here if you see, it is not matching these dimensions, right? So I have made a mistake, I'm so sorry for that. Y train comma y test. Now let's run it. and run this. Yeah, now it's fine. All right, so here we have 491 data points for training our model, and we have 15 features that are going to predict the final class output. All right, so this is our final target variable or final output that we want to predict. So here if I use simply some decision tree, and if I use this bagging classifier which is random forest, let's see what difference do we get, right? So here we are going to see the difference between the simple decision tree and our random forest classifier. All right, so first of all, let's build a decision tree model here. So here let's build a decision tree classifier. All right, and to use this decision tree classifier, we are going to use sklearn package. You can go to Google, you can write decision tree classifier sklearn and enter. You search about it, then you go to this first link that you see, that is sklearn.tree.decision tree classifier. You click here, it will take you to this documentation of this decision tree classifier. All right, so here you can read about all the parameters, how to use them, what are the different parameters that you can tune in, what does they do, how do they work. All right, so you can read about them, and there are some examples here as well. So whenever you are trying to learn any new package or any new algorithm, try to look for this official documentation. All right, so let's head back, and here we are going to use this decision tree classifier from this sklearn.tree package. All right, so here I'm going to write from sklearn.tree import decision tree classifier. All right, and here I'm going to create a instance of this d_tree equals to my decision tree classifier instance, decision tree classifier. All right, now we are going to train our model. So we are going to fit our model here. So d_tree dot fit, and here you have to give your training data. So I'm going to give x train comma y underscore train, and to do the prediction, so prediction, here you have to write pred underscore class equals to d_tree dot predict. So we are doing the prediction here. So here it is going to train. After training this model, we are going to predict. So we are going to write d_tree, that is our decision tree classifier, dot predict, and here this is your train prediction. So pred, let's name it as pred tr. So this is our prediction for training data. So x underscore train. Similarly, I'm going to copy this, and similarly we are going to predict it for testing data as well. Paste it over here and change this to x test. All right, now let's run it. Let's run this. All right, so we have built, and we also have this predicted class. So I think we haven't changed their name, it should be ts, so I have to run it again. So yeah, now it's fine. So we have pred tr and pred ts, that is the predicted classes for training and testing model, right? So now if you check the accuracy, so simply you can write d_tree dot score and you can check that by giving x underscore train comma y underscore train. Alright, and this is going to be your accuracy score. So print, this is your accuracy score for training data, right? So let's enclose it, copy this, I'm going to paste it over here again, and this is for testing data. So this is going to be for testing data, and also change the variable name here. It is going to be x test, and here it is going to be y test. All right, now let's run it and see. So here, if you see, our model is giving 100% of accuracy for our training data set, right? But if you see, we are getting only 0.68, that is very poor accuracy score, right? So here our model is overfitting on our training data, right? So this decision tree is very prone to overfitting here. So what we can do is we can try some different models, right? So here if you try to see it using, let's plot a confusion matrix as well and see. All right, so I'm going to write from sklearn dot matrix import plot confusion matrix. All right, so plot underscore confusion matrix, and here if you plot this confusion matrix, so plot underscore confusion matrix, and then you have to give this actual value and the predicted value. So your y underscore train comma your y, sorry, this is going to be pred underscore tr. Let's run it. All right, so you have to give all right, so you have to give the estimator as the first argument, and then just a second. So here you have to give this estimator. So here what is our estimator? It is our decision tree, D tree, right? So here you have to give this estimator, and if you go and check its documentation as well, and if you want stuck somewhere, you can always write help. Otherwise you can go to Google, write plot underscore confusion matrix sklearn, and always go to this first link that you see of the official documentation. So here first of all you have to give this estimator, then x and y true. All right, so here we haven't given that estimator, so our estimator is our D tree, right, and comma it is going to be your x underscore train comma y underscore train. Let's run it. And here it is giving you this scientific notation. I want the integer, so I can give value format equals to d and run it. All right, so here if you see, this is for our training data. All right, and here if you see, we are not doing any misclassification for this training data. Here we have this we have true positives and true negatives. So our model is giving us 100% accuracy score. But if I copy this code and just copy it, go down and paste this for this testing data. So if I write x test, right, so just write x test, and here as well give y test, and now if I run it here if you see, we are getting this misclassified data points. So here we have 22 and 77, that is false positives and false negatives, right? So here our model is overfitting on our training data. So this decision trees are very prone to overfitting. Now let's work with this random forest classifier and see if we can overcome this problem here. All right, so to do that, first of all you have to import. So we are going to use this sklearn package. So you have to write from sklearn dot ensemble, right, from sklearn dot ensemble import, and here you have to import the random forest classifier. Again I am going to create RCLF equals to, I am going to create an instance of this random forest classifier. So random forest classifier, and again you have to give this the number of decision tree that you want to build, that is your n estimators. All right, so if you go to Google, just go to Google and type here on, that is random forest classifier sklearn, enter, go to this first link here. All right, and again here if you see, you have to give this n estimator, and by default it takes the 100 value. That means it is going to build a 100 decision trees, and then it is going to take the decision from all these 100 decision trees. All right, so this is going to build 100 decision tree and combine their power, predictive power, and take the maximum vote. So we have seen that how this random forest work. Right, so you can specify, change this n estimator values to whatever you like, and you can try out with different values of this n estimators. So let's head back and just keep it default for now. All right, and see if we can improve our model overfitting problem using this random forest classifier. All right, so here I am going to write R underscore CLF dot fit. All right, and here I am going to write X underscore train comma Y underscore train. All right, now we have fitted our model here. Now let's do the prediction. So prediction, and here I am going to copy the code from above, so we don't have to write it again and again. So just copy it and go down, and I'm going to paste it over here. All right. So in place of D tree, make sure you change this to R underscore CLF, that is our random forest classifier, right? So R underscore CLF. All right, now let's run it. Let's run this. All right, so we have run our model with 100 of estimators. All right, by default it takes 100 estimators. Now let's check the accuracy for training and testing. So I'm going to copy this code cells from here. I'm going to go down. So I'm going to go down. I'm going to paste it over here. So check the accuracy score. Check the accuracy score for training and testing our model. All right, so let's run it. First of all, you have to make changes here. That is, you have to give it as R underscore CLF, and here as well you have to give it as R underscore CLF. Now let's run this. All right, so here if you see, this accuracy score for training is 1.0, and for testing we are getting only 0.71. So it is overfitting here as well, but it has decreased somewhat, right? So we have decreased this overfitting somewhat, that is from 0.65 to 0.71, and we can also put constraint on some other parameters to improve this. We will see that. All right, first of all, let's plot the confusion matrix. All right, so I'm going to copy this code cell from here, copy it from here, go down, and I'm going to paste it over here. So just paste it, and let's check this for testing only. So no problem for training, because we are making 100% of accuracy score for training. Now let's check this for testing only. All right, so y test, and here it is going to be x test, and our estimator is r underscore clf. Let's run it. All right, so now if you see, again we are making this mistake. So we have decreased this, which is here. If you see, we have decreased this. This is the predicted label, so this is 0, and this is the true label, this is 1. So here this is your true positive, right? This is your true negative, and this here is your false positive. So this is your false positive. Here if you see, we have decreased this false positive rate, but here if you see, our false negative rate has increased, right? So if you go up and check here, if you see this, here the false positive rate was we were getting 17 false positives, right, and 22 false negative, but now we are having 8 false positives and 27 false negatives, but we want to decrease this false negative as well. All right, so let's train it with different estimators. Now to do that, what I am going to do is, I am going to copy this code cells from here. I am going to copy it. So this is for the decision tree, not for the decision tree. Rather, I am going to, okay, so we are going to copy this code cell from here. I am going to go down. So let's go down. Let's get some new code cells. All right, let's paste it over here. And here I am going to build my model with different number of estimators. All right, so here I am going to write a for loop. All right, so I am going to write a for loop, or the other way would be to check the sorry, the other way would be to do the cross validation here. All right, so you can do that as well. You can go for cross validation, but first let's try out with different estimators. So I'm going to write a for loop for I in range. Let's say I'm going to give it as 0, not 0. I'm going to give it as 10 to 100, and with the step size of 20, we are going to run this decision tree. All right, so let's give a tab here. So we give this 4 spaces, that is indentation in Python. Whenever we write this for loop, we have already imported this package, so no need here. Let's remove it. All right, and here I'm going to create a 2 empty list, that is our tr underscore pred equals to a empty list, and ts underscore pred equals to again a empty list. All right, and here what we can do is we can give n estimators. So n underscore estimators equals to I. So it is going to take this value, that is first, at the first run it is going to be 20, sorry, it is going to be 10, then 30, then 50, and like this it is going to take a 20 steps, and it is going to train our model for this different estimators. All right, so we are going to fit this model, then we are going to predict it, and here we are going to append this. We are not going to store it anywhere. We are going to append so tr underscore pred dot append, and we are appending this training prediction. This I'm really sorry for that, you have to keep it as same. So here we are going to change this. So this is our training accuracy, not prediction actually. So this is our TR accuracy, and this is our testing accuracy. So this is not the prediction, this is in fact accuracy that we are going to check. All right, and here to check the accuracy you can simply write tr underscore acc dot append r underscore CLF, that is the score that we were checking, that is accuracy score. That you could, if you go up and see here, you are checking this accuracy score by writing dot score only, right? So we are going to write that here as well. So I'm going to write r underscore CLF, that is our model, dot score, and here your x underscore train, comma your y underscore train. All right, now let's just copy this line, copy it and paste it here in the next line, and change this TRSCC to TS underscore ACC, and change this variable name from x train to x test, and from y train to your y test here. All right, and now let's run it. All right, now if you check your TRSCC, right, so this is going to give you a training accuracy for different estimator. So for estimator, if you see, you have 1, 2, 3, 4, 5. So we have built 5 random forest classifier with different estimators. So first we are getting 0.99 accuracy, then 1.0, 1.0, and it is increasing only. All right, so here let's check it tr underscore ts underscore acc, whether it is increasing or decreasing. All right, so let's run it, and here if you see, it is increasing as well. So at the first iteration we have 0.65, at second iteration 0.76, right? So here if you see, out of all this second iteration or the second random forest classifier that we built is using this. First it is going to take 10, then 20, right? So the 20, this is a random forest classifier with 20 estimators, is giving us a good accuracy score here, that is 76. But here you don't have to go for the accuracy score, you have to go for either precision or recall, or either check your confusion matrix. All right, so this is your random forest classifier at different with different estimators. You can also increase this estimators, so let's keep it as 200 with the step size of 20. Now if you run it, it is going to take some time, right? So it has run, and here this is your training accuracy, and here this is your testing accuracy. So here if you see, your testing accuracy is not increasing with the increasing if you increase this number of estimators, right? So you have to look for some other method So what you can do is you can try different tuning in different parameters, right? So this is overfitting problem. You can try the cross validation technique, or you can also check for this optimal parameter values using grid search. So that is a topic for some different day. We'll talk about that. So if you want to know what is grid search CV, just go to Google here, then write grid search CV documentation, right? Go to this first. All right, so here if you see, you can use this grid search to find the optimal values for all the different parameters that are there in this decision tree model that we have built. So this random forest classifier we have tried out with just single parameter, that is number of estimators. Now you can also set constraint on the maximum depth of this different decision tree that you are building using this random forest classifier. So you can set constraint for this maximum depth as well. All right. So now let's try out for this grid search CV. So first of all, I'm going to create a param grid, right? And here if you see your r_clf, and if you run it, here you have all these different parameters that you can tune in to get the best possible model for your this data set. All right, so best possible model for this data set here. So if you see here, you have this bootstrap equals to true, CCP, class weight, right, criterion, Guinea. We have talked about this when we were having the session for decision tree classify, right? That we have maximum depth, you have maximum features, max leaf nodes, maximum samples, minimum impurity decrease. So you can tune all these parameters, all right? So you can utilize this grid search package from here, and we will talk about this some other day. All right, so this is your one type of ensemble modeling that we have seen, that is our random forest classifier, which builds several decision trees, right? And this combines their predictive power to build a strong model. So this is one type of ensemble learning technique. There are different ensemble learning techniques, all right? So there is voting classifier. You can read about them. You cannot cover all this in this single session, so we have tried to give you an intuition. So this is your random forest, a very basic and simple ensemble learning technique that you can use, and this is known as your bagging classifier. So this comes under your bagging classifier, all right? And then you have this boosting classifier, which is XGBoost. So I'm really sorry. I'm really sorry. I don't think I will be able to talk more now. I'm sick a little bit, so I'm not able to talk more now. So this is going to be it for this session. All right. So if you have any doubt, go ahead, ask your doubts. This is just a simple bagging classifier, that is random forest classifier, that we have implemented today. And we have seen that it decreases this overfitting problem somewhat, right? So if the data set would have been more bigger, then we could have got a nice, more nice result from this random forest classifier. So if anyone has any doubt regarding today's session, go ahead, ask your doubts, all right? So I will wait for a few minutes. Let's see if you have any doubt. Alright guys, so if you have any doubt, anyone, you can ask your doubts if you are confused. And if you want to learn more and if you want to be informed about our upcoming session and different engaging session on our, you can follow us and join our group on Facebook. There we are going to paste different challenges for you guys. You can participate in that and you are going to get featured on our pages. All right, so you will get featured if you score well. There is going to be a lot of learning. We are going to learn a lot from that group. It is not typical Facebook group. All right folks, so if you want, you can join our group. We will share the link after this session. You join our group. All right, so you can join our group and there you are going to have more engaging session. You will be informed about upcoming free webinars that we are going to come up with, that are in our lined up many interesting things for you. So yeah, do follow us on this Facebook group, and thank you very much for this session. I hope you guys learned and enjoyed. So yeah, thank you very much everyone.